Hello and welcome back to our video. In this problem, we're given that the equation for the speed of sound is a linear function of the air temperature T, and it's given by S of T is equal to 0.6 T plus 331.4. Just rewriting it again down here. We are asked, given this information, what is the best interpretation of the number 331.4? So if we think of this as a linear equation in the form y equals mx plus b, then 331.4 correlates with b. It's the quote-unquote y-intercept. It's really the s of t intercept because we don't have an y and an x, we have s of t and t. But the way you have to think about this number is when x is equal to 0, or when t is equal to 0, y, or in this case s of t, is going to be equal to 331.4. So I'll show you what that means. If we have s of 0, that's going to be 0.6, then t is 0 plus 331.4. 0.6 times 0 is 0 plus 331.4. And therefore s of 0 is equal to 0 plus 331.4 is equal to 331.4. So when t equals 0, s of t equals 331.4. And if S is the speed of sound and T is the air temperature, this is when the temperature equals 0, the speed of sound is 331.4. So what is the best interpretation of the number 331.4 in this context? It is the speed of sound in meters per second at 0 degrees Celsius, when the temperature equals 0. Therefore, A is going to be your final answer. As always, thank you for liking and subscribing. I'll see you in the next video.